having before is I was covering up.
So what is the problem exactly?
Okay, so the problem that we're doing is question 1 from the two-part questions that we're doing in homework A. Question 1 is asking you to consider the IVP, which is the initial value problem. The given differential equation is y prime of t equals y times y minus 2 squared times y minus 10, with the initial condition of y of 0 equaling c. Part A is asking if c equals 8, then what is the limit of y of t as t approaches negative infinity? Part B is asking if c equals 1, what is the limit of y of t as t approaches infinity? Part C is asking if c equals 10, then what is the limit of y of t as t approaches infinity? And Part D is asking if c equals 2, then what is the limit of y of t as t is approaching negative infinity? So step 1 is to take the function as is and set it equal to 0 to find the critical points. So what we do is when we set the equation equal to 0, being y prime of t equaling y minus 2 squared times y minus 10, we set the y's equal to 0, so y equals 0, y minus 2 squared is equal to 0, and y minus 10 is equal to 0. Okay? So we have y equals 0 as one critical point. Y equals 2 is another critical point. When we do y minus 2 squared, setting it equal to 0 gives us y equals 2. And y minus 10 equaling 0, giving us y equals 10 as a critical point. After we found the critical points, what we need to do is figure out if the equation is autonomous, or therefore is it governed by itself and not by x or any other independent variable.
How do you tell the difference?
An autonomous function means that there's no y on the right side. It's only being governed, like I said, by y. In other words, y prime of t equaling y, giving the equation again, making sure there's no x on this side. So once we figured out that it is autonomous, then we go ahead and go on to the next step, which is first off draw a phase line. When we draw the phase line, we pick the points y equals 0, y equals 2, and y equals 10. And what we do is we want to find the slope at those points. And we do that by plugging in those respective numbers into the differential equation. So when we plug in y minus 2, or when we plug in y equals 0 into the equation, we get 0 times 0 minus 2 squared times 0 minus 10. So 0 is negative 2 squared is 4 times 0, so that's going to give us 0. Then we do the same thing for the point y equals 2, where it's 2 times 2 minus 2 squared, 2 minus 10.
So it's 0 again.
So it's 0 again, because right here is 0, so anything times 0 is 0.
Yeah.
And then we get 10 and plug it into the equation. We get 10 minus 2, 10 minus 10.
80 and 0.
10 is 0, so it's 0. So what that proves is that these points, y equals 0, y equals 2, and y equals 10,
all equals 0?
They all equal 0, meaning the derivative with respect to t is equal to 0. So all these, the derivative, meaning that the slope doesn't change. Therefore, the line is linear and it stays on that path. Next we want to do is draw a phase portrait. So once we draw the phase portrait, we plug in the numbers that we have and we check what the phase portrait is looking like. In other words, pick a point above 10, between 2 and 10, and between 0 and 2, and see how the graph behaves.
1 and 5, more than likely.
I'm sorry?
1 and 5 would be the ones.
Yeah.
Okay.
And then we also have to do above 10 and below 0. And so what we do is we pick a number below 0, for instance, -1.
Mm-hmm.
So it's -1, -1 minus 2 squared, -1 minus 10. All set it equal to 0. Oh no, we solve for it, sorry. So then we do -1 minus 2 is -3, which is squared, which will give us 9. So -1 times 9. See, this was
-9.
this I was afraid of. This shit, kind of shit happening.
We'll just edit that part out later.
So we plug in 9. We plug in a -1, I'm sorry. And then -1 minus 10 will give us -11. So we have -1 times 9 times -11. What we're actually concerned about is the sign of the result, which in this case, -9 to negative times a negative is a positive.
So it's 99.
No, times. We're not worried too much about, like I said, the result. We just know that it's a negative. Or I'm sorry, it's a positive. The sign is positive. So anything below 0, the graph will be going up. So now we pick a point between 0 and 2, like 1, and do 1, plug it into the equation. 1 minus 2 squared, 1 minus 10. 1 minus 2 is -1. -1 squared is 1. So 1 times 1 times 1 minus 10 is -9. Positive times a negative will give us a negative answer. So any point between 0 and 2 will give us a negative answer, meaning the graph will be going down. Now we pick a number between 2 and 10. We'll do 5. 5 times 5 minus 2 squared, 5 minus 10. 5 minus 2 is 3. 3 squared is 9. So 5 times 9 times 5 minus 10 will give us -5. So a negative times a positive will give us a negative result. So any number between 2 and 10 will give us a negative result, meaning the graph will be decreasing at any point between 2 and 10. Now we pick a point above 10, for instance, 11. So 11 times 11 minus 2 squared, 11 minus 10. Okay, 11 minus 2 is 9. 9 squared is 81, so 11, 81. 11 minus 10 will give us 1, so 11 times 81, 1. Again, we're not really concerned with the actual result, just the sign, which is a positive. So anything above 10 will give us an increasing function. Now we go into part A, asking us if C equals 8, then the limit of y of t as t approaches negative infinity equals, in this case, it equals 2. Because if we look back into the graph and we look at a number between 2 and 8, we see that it's decreasing and it's going towards y equals 2. Part B is asking if c equals 1, then what is the limit of y of t as t approaches infinity? In this case, y of t will equal 0. Because if we look at the graph, anything between 0 and 2, which 1 is in between 0 and 2, it is going to go towards 0. Now we look at C. If C equals 10, then what is the limit of y of t as t approaches infinity? Since C equals 10, and that was one of our critical points, we see that at that point, the derivative was 0. And since anything above goes increasing and anything below is decreasing, we see that there is no change on that line when y equals 10. Therefore, it equals 10 because it stays there constant. Part D is asking if C equals 2, then what is the limit of y of t as t approaches negative infinity? Again, 2 was one of the critical points, and we see that there is no change when y equals 2. Therefore, the limit of y of t as t approaches negative infinity if c equals 2 is 2. Okay.
Can you double check these if you wanted to look for the exact numbers of C on this particular graph right here?
Well, they gave us the exact numbers of c.
On particular parts of the question, but if you wanted to go back and check for the ones if C were to equal 1,
I explained that when I went into the graph.
Mm-hmm.
When you look at the graph, anything above 10, so any number above 10 will be constantly increasing. We may not know what it's heading towards because the graph doesn't have that, it doesn't go to that extent, but we will know it's increasing. If we look at a number, any number between 2 and 10, we see that it's decreasing. So any number, not including 2, not including 10, between those two numbers will be heading towards x equals 2. Any number between 0 and 2, we see that it's decreasing. So any number non-inclusive of 0 and 2 between those two numbers will be heading towards 0. And any number below 0 is heading towards y equals 0, not including 0.